Are you ready for this? Yes, I am. Are you sure? Yes, I am. Let's go.
Spitzer Space Telescope to determine that there are actually 7 Earth-sized planets orbiting the nearby TRAPPIST-1 star about 40 light-years away. What's more, you can see in this illustration, is that 3 of these planets, marked in...
Okay. 40 light-years away. Some info on a light year. More information on a light year. A light year, or light year abbreviations, is a unit of length used informally to express astronomical distances. It is approximately 9 trillion kilometers, or about 6 trillion miles, etc. This is 1 trillion. These are all the zeros that represent 1 trillion. 12 zeros with 1 unit. Okay? Let's have some more stuff before we go down to other things. Stuff like, simply remember this triangle D, blah blah blah, S times T. The D represents distance, the S represents speed, the T represents time. Distance divided by time equals speed. 120 miles divided by 2 hours equals 60 miles per hour. Distance divided by speed equals time. 120 miles divided by 60 miles per hour equals 2 hours. So I can fairly say that if I have a distance of 100 kilometers to cover and I'm moving at 100 kilometers an hour, I'll get there in 1 hour. Fair enough. Some more rapid information. Fastest spacecrafts so far. The fastest spacecraft launched from Earth was NASA's New Horizons mission, which is en route to Pluto in January 2006. The probe left Earth at 36,000 miles per hour, or 58,000 kph, kilometers per hour. The time it would take such a probe to get to Mars would be bam bam bam. Some more information. Rapid. A list of how long it took several historical missions to reach the red planet. Their launch dates are included for perspective. So, 1 trillion with the fastest craft I have. If it's a manned trip, meaning if there's people on this craft, I don't know if they'll move that fast, but I'm giving it the best shot I can right now. So good. I'm going to divide this by 50. Thousand miles, kilometers per hour, which is equals to, whoa, because we are going to be kind at the end, we are not going to use these numbers. We are going to use 1,000 years maximum speed to get there. Okay, we just roll in some numbers here. So now, if I divide this by 24, what do I get? Wow. So now if I divide this by 365, what do I get? Whoa. So now, if I multiply this by 40, what would I get? Whoa. So I'm just I'm just spinning some rough numbers here. Some rough numbers. I would like to do these numbers on the speed of light. If man could travel at the speed of light, if we can make these numbers disappear. But anyway, I'm going to use 1,000 years to get to Mars. Or the 7 exoplanets, which are much more further, which is the calculations we just did. Because Mars is just our backyard. Compared to these kinds of years, then we can get to Mars in less than a year. With manned vehicles, probes can go real quick, But will we go that quick to Mars with men on board? But these are numbers for the 7 exoplanets. And I'm not even saying how much years these numbers represent, because I don't want to discourage myself. So, for my own entertainment, I made a small graph, right? This represents this craft, whatever craft that will be built by these people to cover this distance, to get to these 7 exoplanets, right? So our sun, this is our solar system, down to Pluto and whatever. We have Earth somewhere around here. So we are leaving our Earth and we're going to a mission. And it's going to take us 1,000 years because I'm kind. Okay? I'm very kind. I'm going to imagine that we can get a craft that can go so fast that it will only take us 1,000 years to get there. Now this chart will go up much further. For example, up to 10. Because we are going to divide these distances. Separations of 100 years. Left Earth 100 years. Because my point here is that the first astronauts who leave Earth will not make it to these 7 exoplanets. I'm so fatalist. No. But guess what? Someone will make it. But who? Their kids. The point is, these people will be having kids on these crafts. And I said crafts because if a craft is launched every 10 years, for example, they'll be following each other in a chain. Distances separating them by 10 years. We're not going to this right now. And the benefits of having a chain of crafts every 10 years, launch of every 5 years. We are just going to prove one case today. After 100 years, if an astronaut leaves this planet, if there are 10 of them in the plane, in the craft, let's say at the age of 40 or 30, they have kids. Because they have to train these kids for at least 15 years to take command of these crafts. These kids will live up to 10 years before they can have any serious studies. Okay? at the age of 10 years, they can start having serious studies with their parents. Their parents will teach them for up to like 15 years how to handle these crafts, physics, how to avoid obstacles, black holes, how not to get lost in different universes, you know, to keep on the mission. However, after 100 years, these people, according to our lifespan, which is an average of about 100 years if we are lucky, the first astronauts will die, but their kids will take command after the second 100 years. After 200 years, their kids will die, but their children's children will continue the mission, etc. There are going to be a lot of generations on this trip. So I'm going to stop at 3. Between 1 and 3, there could be 4 generations, even 5 generations of kids. This thing is going to take a long time. This is the end of part 1. Disclaimer. Yes, this is my disclaimer. Okay? This video is not, all the points I made here is not coming from a NASA scientist, okay? I'm expressing myself, my thoughts. Anyone can place their comment or what they think, but don't take it for, how you would say, information coming from a top scientist, okay? YouTube is a free place. Once you follow the guidelines, and I make what kind of videos I want, okay? If somebody have a problem with me being kind and place it down to 1,000 years, or if somebody think I'm still being harsh and putting 1,000 years as being too much, I am not a rocket scientist. Give me a break. And AFP Connects is out. And PS, if you can bring it down to at least 1,000 years or under 1,000 years, be my guest. This is not a trip going to the moon. So, as I said, I was kind, and the results I got the first time on the 1 trillion kilometers, I did not even use it. I used 1,000 years. Well, let's go all the way. I wonder if this calculator will be able to give me the numbers. Hope we don't kill this calculator. It will do the business. So, yeah. I'll say no more. Oh, if someone wants to play smart or have some fun, you know, if you want to fantasize that we are going to have the craft that's going to move at the speed of light, here's the speed of light. So, just transform that to kilometers, convert it, and then do the maths. And the AFP Connects is out. again